Okay, I'm waiting for you. If we look at the gold sheet, okay, here are the things that you're going to be able to do by the time we get to our chapter test. Okay, it'll also tell you which ones each day that we're working on. Okay, so today I can solve a linear equation with a variable on one side. That's what we're going to do today. That's what we're going to do on Friday or on Monday. Okay, but today is day one. You can see what we're learning. There's a little checkbox. This is your homework. Now, page 8, is that from that journal? No, this is from the book. Do you have a book? No. Where do you find page 8? On Google Classroom. Okay. Your homework will be on Google Classroom. The only time it won't be on Google Classroom is if I give you, oh wait, it still would be, but if I give you a worksheet, it'll still be on Google Classroom, but with you're in class, I'll give you the worksheet, okay? I will also post answers to these book assignments. Now they won't be like worked out like last night's was, but if it's a book assignment, I will post the answers for you to check. Does that make sense? Brooks, I really hope you're paying attention. Okay. So, do we understand that this page 8 is not from the flimsy book I gave you? It's from the book that you don't have. So you find this on Google Classroom. Okay, go ahead and in your student journal, that's what that blue book is called, turn to page 4. Yes, so do yours to keep. Perfect. You'll bring it with you every day, Ellery. Okay, Karen? Okay. All right, so here we go. Yes. I mean, technically you can, but I wouldn't, because in this class, you will have a midterm and a final. So at the end of the semester, there will be a test that covers everything from the semester. That's not to freak you out. That's to prepare you for high school. So I would not rip anything out of here because you might need to reference it later. Connor.
You get to use the already solved problems to find the other problems. You get to use these worksheets to help us on the thing.
No, but they can help you study. Okay. All right. Fun time. I want you to cross these 3 things out right here.
Wait, we don't have the. Oh, never mind. I just see it.
Nope. Okay. A constant is a number without a variable. Okay, well, that's cool. What's a variable? Well, I wouldn't say undefined, an unknown number. Okay, represented by a letter. Okay. An unknown number, whoever said that, that was good. Represented by a letter. The most common variable we will use is x. Okay. Just waiting for you to write it down. Okay. What do we call the number in front of a variable? Yep. Carrie?
Coefficient.
Yes. What page you find that on?
I actually didn't see it.
Mm-hmm. Okay, now, an equation has an equal sign. If there's no equal sign, it's just an expression. But an equation has an equal sign. Okay. So, if we have something that looks like this, raise your hand if you can tell me what the coefficient is in this equation. Brooks. The coefficient is what, Ian? 4 is the coefficient. Okay. Brooks, I'm going to come back to you. What is x? A variable. Okay. And then 1 and 9 are both constants because they don't have an x or another letter with them. Okay. So if you need that reminder, this is the coefficient. This is the variable. And this is the constant. Okay. Now, we are going to be solving equations in this chapter. Okay. And when I ask you to solve an equation, I'm going to ask you to find the solution. Solution is just a fancy word for what?
Answer.
Okay. It's a fancy word for answer. So a solution is a value that makes the equation true. Okay. We'll even get into some equations that don't have a solution. There isn't a number that makes it true. I know, that's crazy, right? Okay. But when I ask you to find the solution, I'm asking you to find an answer. What number makes this equation true? And I'm going to teach you some strategies to where it's not a guess and check. We're going to be strategic about it. Okay. Now, we're going to talk about one-step equations today. And as we talk about these one-step equations, first of all, it should be a little bit familiar from Advanced Math 7. Okay. I'm sure. Okay. Now, inverse operations. Okay. You are going to hear me say this a lot. Inverse operations. Okay. An operation like addition, subtraction, multiplication, division. If they are inverse operations, they're going to undo each other. Okay. And we're going to spend the next like 5-6 minutes talking about what the inverse operations are. Okay. We're just going to dust those cobwebs out of your brain. Okay. Oh, I am ready to do some algebra. Are you?
Yeah.
Okay, don't answer that.
I don't want to do the finals because like after every unit, I pretty much just forget it.
You're not going to. Okay. All right. So the addition property of equality. If A equals B, then A plus C equals B plus C. This is telling us that it is okay to take an equation and add the same number to both sides. Okay? As long as we add C to the left side and we add C to the right side, then we balance our equation, right? So if I have, write this down, x minus 1 equals 7. Write it down. Okay. Now, a lot of you can tell me right now what x equals, but let's talk about why I'm writing this down with this property, okay? If we want to get x by itself, 1 is being subtracted from x. Well, what operation is going to undo subtraction? Addition. So we can add 1 to both sides, but remember, if we do something to the left side, we have to do it to the right side, so it's still equivalent, okay? So these cancel, and now we have x equals 8. You thought I was going to teach you something crazy hard on the first Friday of school? Yep. Second Friday of school.
Wait.
Yeah. What's the question? Okay. All right. Hey, let's turn the page. Voice is off, please. Voice is off. Okay. All right. We have the subtraction property that tells us if we have A equals B, we can subtract C from both sides of our equation and we still have a mathematically true statement, okay? If we subtract something to the left, we have to balance it out and subtract it to the right, okay? When would that come into play? If we had x plus 7 equals 4, okay? If we wanted to get x by itself, what is the inverse operation of addition? Okay, so we could subtract 7 from both sides of our equation, and we'd be left with x equals -3. We're also going to need to teach Harry how to do math because he thinks that 5 plus 4 plus 3 equals 2. And I just really don't think that that's right. I know.
Yes.
Isn't it 5, 4, 3?
Yeah.
Yeah. Okay.
Oh, no.
It's 6, 4, 3, 2.
6, 4. Dang it. Sorry. 6, 4, 3 equals 2. This is what Harry thinks.
What's?
I'm so confused.
Okay, this is, so Harry has a bracelet that says this. Shortstop throws it to second base to get an out, throws it to first base to get a double play.
Good job, Harry. Good thinking.
Because the shortstop is position 6. Because the pitcher is 1, the catcher is 2, first base, second base, third base, shortstop. Okay. All right. It doesn't matter. I just wanted to teach him. All right. Multiplication property. If A equals B, then we can multiply the same number to both sides and we still have a true statement. Okay. So if I have something like x over 5 equals 2, what is the inverse operation of divide?
Multiplication.
So we can multiply both sides by 5 to get rid of that divide by 5. And we are left with x equals 10. Why are we chit-chatting? Okay, last one. The division property. If A equals B, then I can divide both sides by the same number as long as I am not dividing by 0. Do not divide by 0.
Is that the one that's got no friends?
That, yeah, your calculator will explode. Okay. All right, so if I have 5x equals 45. 5 is being, okay, this is your last warning, and then you get a new sitting chart. Do you understand? All 4 of you. Okay. 5 is being multiplied to x. What is the inverse operation for multiplication? So we divide both sides by 5, and we get x equals 9. Oh. I like to be able to move around the room. Yep. Yep. Nope.
Sometimes it does, you can get like video.
All right, so this is what I'm gonna have you do. You and your elbow partner are going to answer number 1, 4, 7, and 9. You have 1 minute. It's plenty of time, people. It's plenty of time. Six. I'm sorry, I messed it up. Oh yeah. But I mean, it was work, so you double play. Boom. It's oh.
You're about what I just told you. What are the different
Someone who did that.
I think it's more than.
But like 15.
Yes.
If we accidentally work for the semester, then I'm screwed. But that's gonna be harder when you deal with right? Wait. I know that the first was like an hour.
Right. I'll give you plenty of time. Now we'll get multiple days.
I don't want to take
It will be okay. I promise.
This is easy stuff.
And it will, and what is hard will feel easy by the time we get there. Okay, it will be okay.
I'm not talking about hard.
Don't even think about it right now. Okay. All right. Let's talk about number 1. Okay. Oh, this fan is really excellent. All right, Kaden, what do we do to solve for x and or to solve for w in number 1? And then what do we get? Do you agree with Kaden? Amazing. Great. Okay. Carly, and number 4, how do we get z by itself? You agree with Carly? Awesome. Okay. Ask Kathy. Okay, Cassie, how do we solve for B in number 7? Okay, well, it would be negative.
Oh my bad, I'm looking at it, I'm sorry.
Negative. I think it's just 13, isn't it?
Yeah. It is.
Yeah. But it's okay. Don't cry. What did I say? Are mistakes bad? No, mistakes are great. It's okay. We're easing back into things. I don't want you to ever give anybody a hard time for getting something wrong. Gabe, how do we solve number 9?
You multiply both sides by 2.
2?
Negative.
All right, so n equals
Positive 30.
+30. I'm sure you have nothing to do with it. Okay, I would like you to read through number 10. Sure.
Wait, 10 animals or 10?
Just 10. I'm sorry. I need to drink my water.
Solve it.
I just want you to read it.
Okay.
I don't know how to solve it.
You don't know how to solve it?
Okay. P represents the price of the headphones. You have a coupon that subtracts $17.95 from the price. Can you go now? Okay. You pay $71.80 for the headphones. How would we write that equation? Henry?
17.95 plus.
Oh, interesting. That's one way. What's another way?
P minus 1795 equals 7180.
So then when we solve this, we would add those together, which is what Henry said. And we get 89.75. Is that right?
Yeah. Yes. I've done in my head.